Now we're going to look at doing work. So we have two pictures here. Who is doing work? There's this student in the library doing work, and this boy here doing work. Now, who is doing the work? You may think that the guy in the library is doing the work, but the answer is they're both actually doing the same amount of work, and that is no work whatsoever. In fact, you're probably sitting down looking at this screencast now. Are you doing some work? No, you are not doing any work. I'll explain why. In physics, for work to be done, you need a force that causes some movement. So if you're sitting there reading a book, you're not actually doing any work because there's no movement. So what is doing work in the physics sense? To do work in the physics sense, you must exert a force which works over a distance. And this uses energy, which is measured in joules, and that's going to be the work done. So you need a force to be applied, and you need a distance to be travelled, and this distance must be in the direction of the force, otherwise that force is not doing the work. So the work done is simply force times distance is equal to the work done. And this is a triangle that we can use. Work done is equal to force times distance. And we use the triangle like this. The work done is equal to force times distance, which means if you want to find the work done, that's equal to force times distance. If we want to find the force, that's equal to the work done divided by the distance. If you want to find the distance, you know the work done and the force. It's the distance is the work done divided by the force. And that's all there is to it. Now here, a block is pushed with a force of 200 newtons for 2 meters. Like so. So the work done is force times distance. Work done in joules is force times distance, which is equal to 200 divided by 2 is equal to 400 joules. This is the work done in moving that block through 2 meters with a force of 200 newtons. But what happens if it slides down 5 meters or so as well? We still have the force 200 newtons to the side and a distance of 2 meters, but let's say it does this and goes downwards, and that distance is 5 meters. What is the work done by the force then? Now the key word is by the force, because even though the block moves down, the distance must be in the same direction as the force. And since the force is from left to right, so the distance must be measured from left to right, not diagonally from left to right. So it's going to be 2 meters, not 5 meters. So work done is force times distance. 200 times by 2 gives a work done of 400 joules. And it's not going to be 200 times by 5, which is 1000 joules. Another example of doing work. These guys are pulling with a force of 3000 newtons through a distance of 3 meters. What is the work done? How much energy do they need? Work done is equal to force times distance. F times D, 3000 times by 3, gives a work done of 9000 joules. What about levers? What is the work done by a lever? Well, there are two parts of work that being done here, the left hand side and the right hand side. Let's look at the left hand side first. The work done is equal to force times distance, which is 100 newton times by 3, which gives work done of 300 joules. And on the right hand side, work is equal to force times distance, which is 200 times by 1.5, which is also 300 joules. Notice that the work done on either side is the same. So even though the force is greater, or double the amount on the right, the distance that is moved is actually half. So the work done is going to be the same. Force times distance is the same on each side, and it gives the same energy, the same amount of work done. Now here we have a common confusion. Santa is picking up this box. He picks it, the box weighs 250 newtons, and he picks it up by 1 meter. And then he walks off against the resistance of the snow that he's walking through with a friction of 100 newtons, and he walks 12 meters. How much work does Santa do? Well, he actually does the work in 2 stages. The first stage, the first piece, let's say, work done is equal to force times distance. The force is 250 times by 1, which is 250 joules. Then secondly, he walks 12 meters with a force of 100 newtons, and that's going to be 1200 joules, 100 times by 12. Notice that the 2 pieces of work are done in different directions because the force is in different directions. Now, what is the work done to raise a block up a ramp? Let's say the block weighs 800 newtons, that's its weight, and it's dragged 8 meters up the ramp, but the ramp is only 2 meters high. So what is the work done to lift it up that height? Now you have to decide in which direction is the force, and therefore what is the distance in that direction. Well, the force or the weight is acting in the vertical direction, so you must take the distance in the vertical direction. So you must take 2 meters as being the distance travelled. Now the work done is force times distance, which is 800 times by 2 gives us 1600 joules. So that's the work done in lifting the block up the ramp. An extra problem. What is the force that is needed to drag the block up the ramp? Well, what force would be needed to do that? Let's assume that it takes the same energy. In other words, there's no energy lost against friction. We know that the energy used is 1600 joules. The work done is equal to force times distance. We know the energy is 1600 joules. We also know that the distance up the ramp is 8 meters. So 1600 is equal to F times 8. So we need to find F. We divide both sides by 8, and we end up with a force of 200 newtons. So by dragging the block up the ramp, it only needs 200 newtons, but it has to go much further as compared to 800 newtons, which is the weight. So a ramp, or in other words, in the science terms, it's called an inclined plane, is actually a simple machine. So that was quite straightforward, I think. So let's say, yeah, easy peasy, lemon squeezy.